He has recently embraced the use of artificial intelligence, leveraging AI-enabled security services of Amazon Web Services. Hemanth is a proven hands-on leader with over 15 years of experience and expertise in technology, transformation, innovation, thought leadership, DevOps, DevSecOps, Cloud, IaaS, SaaS, go-to-market strategy, security, and infrastructure. His specialties include strategy, governance, metrics and performance, management, domain technical architect, B2B, B2C, technical lead, SOA architect, object-oriented architect and designer, risk management, outsourcing and offshoring strategies, turnaround and change leadership, and application portfolio management. Please welcome Omar and Hemanth.
Thank you. Can everybody hear us? All right. So far, the talks across the last 2 days have been heavily focused on a lot of the AI tools and AI capabilities. Here, we're trying to give you a perspective from a customer journey, where our company, as a part of our digital transformation strategy, how we transform the organization. And we'll get into some of the AI and ML tools we're using, but I kind of want to focus on all the things that we are doing differently as we move to the cloud and help towards getting AI as the next stage. So. Sorry, I'm trying to.
Yeah.
Okay.
Oh, you missed the slide. Okay.
All right. So let me go back. I think I did
Missed
too much.
Yeah.
All right.
That's it.
Okay. Perfect. So I'm getting too click happy. So again, as I said, our talk is mainly focused on how we do security governance in the cloud and how we operate at scale. So a few of the most important factors in that is organization and culture. This is probably, sorry, again, okay, all right. You're forwarding it? Okay, perfect, thank you. So organization and culture is one of the most critical linchpin for security because you can't have a reactive organization, and culture is very important, where today security is everyone's responsibility, right? It's not just a security engineering staff, right? And then we talked a lot today, various speakers talked about sanity of the security. All that comes with good architecture, right? Incorporating security principles in your architecture right up front helps downstream, right? And as a part of enabling that is how do we enable a pipeline, a DevSecOps pipeline as a mechanism to enable a lot of the security practices, right? And how do we scale and handle the pace of innovation? Every day, new products are coming out. Either new attacks are coming out, or new products or new services offered by various vendors are coming out. So how do you manage and operate at scale? So those are also those challenges, and that's where some of the AI practices come in, right? How do we use AI and ML in terms of scale? Because it's all about trying to still have a small team, but being able to handle huge amounts of data and security risks across the public cloud enterprise, right? And then how do we use a lot of the tools day in and day out to help most of the either development staff or engineering staff to help automate a lot of the security. So in terms of organization and culture, the most important thing is, again, it's a shared responsibility model, right? In the past, historically, it's always been a finger-pointing exercises in most enterprises, right? Security is always somebody else's problem, right? We're transforming that and making it everybody's problem, right? So it's the way in an agile world, right? It's a shared responsibility model. And then you can't have responsibility without accountability, right? How do you take the responsibility that you give for security to various teams, but at the same time, not have accountability? So accountability also follows the shared responsibility, and that helps build a better culture, and culture is very important in having this a knowledge of security, a knowledge of the threat vectors, right during at the early stages, right? Everybody feels responsible. Everybody takes necessary actions. You still have a lot of the guardrails that are needed, but you make it everybody's shared responsibility and accountability, right? So one of the roles we've done is embed the security role as a part of the squad, right? So in an agile world where you have different product teams and different squads working on different products, you embed security as one of the roles in the squad, right? And a high performance team is another very important factor in enabling this cultural transformation to help a better secure product out there. The last but not the least is, again, a very common theme in large enterprises that we have seen is whenever there's an issue, right, due to the very nature of how we operate, right, there's a constant finger-pointing exercises as which team or which group caused the issue, right? So the most important part of that cultural transformation is also in the event of something going wrong, you create a culture of openness and ability to share what we call blameless RCA. That's become a big factor now. I think Google has championed that in terms of how they created the SRE model. But that's kind of a very core linchpin of that cultural transformation. As you talked about, a lot of the talks today have focused how do we enable security not just at the end when there's deadlines and everything that you have to meet. You have to shift left. And the only way you shift left is you enable security by design, right? So again, in the public cloud, a lot of these things makes it a lot easier. And once you have some of the policies in place, it gets very easy to move security to the left. Again, these are fundamental architectural principles like least privilege access, right? Mainly focused on a public cloud environment, how you enable just the least privilege access to users just to the services they need and not to the entire stack, right? Another important factor in terms of security architecture is a layered defense, right? You usually in the traditional sense, you had just a perimeter defense, right? But as you go and migrate to the cloud, enable that cloud journey, it's not just the perimeter you're blocking. At every stage, you have security inbuilt, right? And then the last piece of the architecture is also configuration management. So most security issues are usually caused by human errors, right? That's a dirty secret nobody tells you. Some engineer, there are always malicious attacks, right? But the non-malicious ones are not by external. There's a lot of internal employees or somebody fat-fingered something or somebody accidentally did something, right? So how do you prevent that? In terms of architecture is you enable configuration management. Whatever tools are available in terms of, there are a lot of open source tools, and we use Ansible, for example, to automate and use configuration management across our cloud infrastructure. And as I said, the next pillar is taking this architecture and building a pipeline. When I say building a pipeline is how do you take development teams which are constantly developing, right? How do you take these policies and these rules and the security postures a company may have, and how do you make that into an enforceable pipeline, right? And these what we call security gates. We'll delve a little bit more deeper when Omar is talking on various gates we use in our practice today. But those are the gates you use as code moves, as developers write code from development environment, a test environment, or go to production. You have various gates to help security, embed security right early on, right? So that that's how you enforce that. It's very easy to say, oh yeah, we do security, but how do you enforce that? That's how you enforce it. You enforce it using pipelines, right? We've also focused on policy, developing the policy as a pipeline, right? A lot of organizations have policies. If the policies are not enforceable, they're not worth anything more than a printed sheet of paper, right? So how do you enforce policies as pipelines? And some of the examples Omar will talk about will cover that. And we also focus a lot on rehydration. So rehydration is a concept, again, very popular only in the cloud, where servers are treated as cattle, not pets. I don't know if you've heard that. So that automatically drastically reduces your security risk exposure, right? So a lot of times as machines or servers are running for years and years, what I call people have a server hugger mentality, right? So you kind of hold on to that server lives and has, like a pet, you name it, you kind of associate it. And the security threats in it, you might patch it, but the patching, I mean, there are standard vulnerabilities they patch against, but the other things which a human mistake or anything can go undetected for years, right? So when you start treating servers like cattle, not pets, that drastically reduces your threat exposure. Of course, we also do traditional patching, but how we automate, we completely automate our patching, at least in the public cloud. So the other important challenge is how do you scale and keep up with changes, right? Both from an internal employee and the tools out there, right? So what we do is, in order to operate some of these rules and these best practices, we translate those best practices into enforceable policies. A simple policy could be, hey, we don't allow anything other than port 22 to be open for SSH or something like that. And that could be a policy, but as long as you can't enforce it, then what's the point? It's not like in a traditional world, you'll have a security engineer review it. How do you operate at scale in an agile world, but still be able to enforce those policies? The other thing we've also done, which kind of helps a lot, is, as I said earlier, we embed the security role in the squads. But as you scale up and have multiple squads, multiple product teams developing different applications, how do you create, in an agile world, it's called a chapter. How do you create a chapter where the security personnel who are, or DevSecOps personnel who are in those product teams can come to the mothership and exchange ideas and cross-pollinate and go back to their product teams and start enforcing some of the best practices, right? And lastly, we're a big champion of open source within our company, and I think we've derived a lot of value for a lot of open source tools. I can very confidently say that a lot of times they're your best friends. That's where you start, right? Especially in the public cloud arena. There's tons of tools out there available which kind of help you get up to speed, and sometimes those do as good, or if not better than most commercial tools out there. So when we want to talk about the security automation tools that we've used in our organization, I kind of want to break it down into some of these areas. Again, Omar will get into some of the details about the technology architecture on each of these tools. But fundamentally, focusing on governance, how we use a tool called CloudSploit to help with our governance across our public cloud space, and how we use another tool called Cloud Custodian, right? This is another open source tool developed by Capital One, and they've open sourced it to the community, and it is phenomenal in terms of enforcing those policies, right? So we have a lot of rules and policies, say everything has to be encrypted. There is no one actually signing off and watching every time. Rather, we kind of automate that using Cloud Custodian, and even if anybody spins it up, within a matter of seconds, that infrastructure is shut down automatically, right? And you get an email, and that person gets an email, they've violated the policy. So that's how you operate at scale, right? So in respect to AI and ML, I think that is, again, the core area that we are now getting to that, and we'll talk about how we use Amazon's Guard Duty, which is a tool which can help with the anomaly detection. So a lot of times you have tremendous amount of data, and how do you identify the needle in the haystack? And how do you identify problems early on, attack vectors that come on, and then they can look at your data, and we've had actual examples of maybe Bitcoin mining, and Omar, again, will talk to you a little bit more detail on that. And also we use something called Amazon Macy, which is a AI ML tool which looks at your data. We have large amounts, we have a huge data lake. How do you make sure that the data lake running in the cloud doesn't have PII data, or if it's not supposed to have, right? So again, you can't allow just a human to go through terabytes and petabytes of data. You use machine learning there to help automate that and identify that needle in the haystack. In terms of pipeline, which I talked about earlier, is we use, again, right when we build our infrastructure as code across the public cloud, we use various tools, and right up front, even before building, there's checks that we do if it follows the best practices. And rather than doing some of these post, this is pre-build. We can check our CloudFormation stack against tools which will help that. And we also have runtime RASP tools, which will help our containers running in the cloud or our Lambdas running in the cloud. How do we protect those? That's the next big word, right? So servers are almost now, as you see companies developing new products, they're all going serverless. With serverless, how do you handle a lot of these security challenges? Because there is no server, there is no perimeter, there is nothing, there is no agent that you can put on, right? How do you handle security at that point? So you need better tools, better capabilities to handle the emerging technologies. And again, as a part of our pipeline, how do we make sure that we have different gates? And OWASP, ZAP is another very common security tool we use for penetration testing. Again, fundamentally, the foundation is still the most important part of any security practice, right? And we'll use a lot of tools in terms of hardening our images and making sure that they are audited before we spin them out and give it to our other developers or different parts of the organization, right? And we use encryption everywhere, and we use a key management system to be able to encrypt our data both in transit and at rest. And Omar will also talk about how we use automated incident response today in the cloud to help with, again, the scale and the pace and the basic foundations of everything we do in the cloud. So again, once we go into the details, it's all about how do we take these best practices and convert them into enforceable policies. So off to you, Omar.
Okay. Thank you, Hemanth. As Hemanth mentioned, that we are a DevOps shop running on AWS cloud, and we use a lot of tools, quite half a dozen tools. Some are open source, some are AWS native services, and we also use some of the third-party tools like CloudSploit and PureSec for the serverless functions. So talking about the governance in cloud, we use something called Cloudsploit that basically is a scanning tool that gives you alerts for any kind of misconfigurations on the resource level. Say, for example, a developer or a platform team is trying to spin up an EC2 instance or an S3 bucket that's not encrypted, or it's trying to open the security groups for that instance to the world. We get the alerts with the help of Cloudsploit. So basically, it's also based on AWS on Lambda. It listens to all kinds of CloudWatch events triggers, and based on the alerts, we have routed these alerts to, say, we can put it to Slack, we can put to your traditional SIEM solution for more granular rules. It can also give you the security best practices. Depends on your organization, if you're dealing with PI or PCI data or even HIPAA. So you can download reports based, and you can run it against your accounts, and then it can give you the reports against these best practices. And also, it can give you best practices for the Center of Internet Security Standards. So you have a lot of levels in the Center of Internet Security Standards. You can level 1, level 2. It kind of cuts that noise and provides you a curtailed dashboard that's very relevant to your use cases. Now, continuing with the governance, like Hemanth mentioned, that cloud is elastic. I mean, you have developers and the platform teams spinning up resources in cloud, maybe in tens or even hundreds in number, and they are basically huge EC2 instances. Say a developer is testing out some use case and spins up a C4X large, which is a heavy machine, costs you thousands of dollars. And it's lying there in your account for months and costing you money. So what Cloud Custodian does is basically it has a Lambda engine, and your DevOps engineers can write rules. Say, for example, you can shut down the instances 6 p.m., your business end of business hours, and it can spin up those instances back 8 a.m. So all your dev environment, which is being tested and which is costing you money by keeping it running, can be automated, and it can be shut down as per your requirements. And from the security perspective, Cloudsploit was more of a reactive control. This is more of a proactive. You're kind of confronting your developers with a tight security policy. Say, for example, I don't want anyone to spin up an S3 bucket that is unencrypted. I want them to spin up instances with particular tags. So as you move a lot of workloads to cloud, resource tagging strategy is an important factor. So you define predefined tags, and you want your developers to follow the tagging strategy. If they are not following it and spin up an EC2 instance, say they don't put the tags, the EC2 instance is shut down. They get a message saying this is shut down because you have not followed the security standards. So it helps you in the encryption, security policies, as well as the cost management. Talking about AI ML, as Hemanth mentioned, we use GuardDuty. This is an AWS service we're relying on in terms of a threat intelligence tool. So what it does is it takes logs from networking logs like DNS flow logs and your VPC flow logs, and also it takes the CloudTrail logs. Those are the API events. And it's pretty cool because what happens is it continuously monitors the detection pattern of your login of the employees. It's just one of the use cases I'm trying to explain. So you're logging from a particular CID range, you're logging from a particular machine, you're logging from a particular location. And the machine learning algorithm runs in the background and records all these parameters. Now, the moment a developer is logging from a particular location for almost a month, and it detects all these parameters with the help of DNS flow logs, your VPC flow logs, and as well as what kind of CloudTrail API calls he makes. And if he's logging from a different location, if there is an anomaly, you get an alert. So say, for example, yesterday I was trying to log in from here. I have been logging from Dallas from almost 2 years now. And I was logging from here. Someone was bugging me to log in and do some work. When I tried to log in, I got an alert saying there is an unusual login from Omar from this location, and we can route all those logs to Slack or your SIEM solution. And the cool thing about it is that you can actually cut the noise in terms of dividing these alerts in medium, high, and low. So you can route these high alert logs to with an SNS notification to your, say, security leadership, so that they're alerted. Say someone is trying to run a Bitcoin mining from your environment. And it has got pre-detection rules set up for the instance compromise, for the Bitcoin mining, for your cryptocurrency. And also, if you're thinking about what it does with the Cloud Trail logs, those are nothing but the API logs being logged, whatever you do in AWS console. If your EC2 instance is trying to run a port scan against an external machine, if you are a penetration testing company, then it's fine. If it's not, then there's a serious risk. Some machine from your environment is trying to run a port scan, and it has got the detections based on that as well. So you can actually figure out what kind of outbound connectivity your machines, your EC2 instances are making. Say if a machine is trying to push a lot of data to some outbound server. So it can actually provide you alerts based on that. And also, you can centralize guard duty. So with AWS, you can have a lot of accounts. I mean, how do you have a single pane of glass? So you can have this guard duty centralized in one account, and you can have all the child accounts sending the guard duty alerts to one centralized management console. So that if you have hundreds of AWS accounts, you still have one single pane of glass. And any kind of, you can list down all the AWS account and their threat alerts individually in that single pane of glass. Continuing on the AI ML tools that we leverage at Neiman Marcus, Amazon Macy is also an AWS service. It basically detects, classifies, and identifies any PII identifiable data or any kind of API access keys that are being uploaded to your S3 buckets. Now, S3 is a service that's being widely used by AWS customers as a landing zone for putting lots of data in it. And then the data analytics team, they perform machine learning and do a lot of things with that data. So it's very important from the data security point of view, what kind of data goes to your S3 bucket. And how do you detect if it's a PII data, if access keys are being uploaded as part of the source code. So it has a machine learning algorithm that kind of detects and puts your data in the risk score of 0 to 9. So it depends on the criticality of the data. It can put the risk score on that data, and then you can set up alerts on the data. Also, if someone is trying to open up the S3 bucket, if it is a sensitive S3 bucket, it has got PII data. Security sets up all the encryption and all the security standards for the S3 bucket. If someone is trying to open up the S3 bucket and change the permissions of the S3 bucket, then it can also set up an alert. You can use various AWS services like Athena for running a query on the data, and also you can use the visualization tool called Amazon Athena for the graphs and other visualization. In terms of the access control, like I mentioned, that if someone is trying to download data from S3 bucket, now we are talking about the machine learning anomaly detection. If someone is trying to download the data from S3 bucket at an odd time of the night, then it also triggers an alert saying some developer is trying to download data from S3, which is sensitive in nature, which is classified as the high-risk data. Then it can send alerts to your Slack or your traditional ASIM system. So it's pretty much integrated with SIEM and as well as your Slack channel in Neiman Marcus. So talking about pipeline, like I mentioned about CloudSploit, so there's a tool in CloudSploit that helps you to run scan against the CFTs. So your platform engineering team usually runs and creates these CFTs for launching the resources in AWS. So it's important that you have some kind of a gate check in the pipeline to see if there's any kind of a misconfiguration in that CFT. If a dev is just spinning up an EC2 instance with an EBS unencrypted, then we can have Lambda call the API of CloudSploit and get it scanned. And so that the pipeline stops. There's a gate check that helps us to kind of look for such anomalies. So everyone wants to go serverless, like Hemanth mentioned. So Lambda function is an important parameter in the serverless framework in AWS. So for the traditional firewalls, it's not possible for them to be inline when a service like SQS sends an event and a Lambda function gets triggered. So you really don't know whether there is an imposter who is trying to inject some kind of event data injection types in that process. So we're using PureSec, which is nothing but a firewall for serverless. What it does is it helps you to control the outbound connectivity of what your Lambda functions can do. And also, if there are over-permissive IAM roles, say, if a dev gives a Lambda function administrator access in AWS, it can immediately point it out. And it gives you a proper dashboard and helps you to identify real-time alerts if there are any web application attacks, like SQL injections on the code, the Lambda functions. And also with Lambda, you have a lot of these third-party package dependencies, like NPM packages, being used as a part of the Lambda function code. It also detects any kind of vulnerability and scans those packages, third-party packages. This is an open source web application security project. Everyone must be aware of this. They have one tool called Z Attack Proxy that's nothing but a vulnerability scanning tool. And our penetration testers use it as a part of the testing out the vulnerabilities in the web applications. So it typically targets you and covers top OWASP top 10 attacks. And this is a useful tool and open source used when you're trying to test the applications before you move it to production. Now, this is what we do at Neiman Marcus in terms of the Army Builder. Hemanth talked about how we inject security, how we make sure that we introduce security at the base, at the root of the cycle. So if you see this, we are all aware about the Golden Army process from our on-prem world. You have got an army, a public army from AWS that you want it to be blessed and you want it to be secure as per your security posture of your organization. You don't want platform engineering team spinning up an EC2 instance with a public army which does not have the security controls, the monitoring controls. It does not have agents for the scanning. So that's how we came up with this Army Builder. It's a pipeline. So we rely on the Git equivalent of tools as AWS code commit, and we also use AWS code build for the code build purpose. And in this diagram, if you see that we are using something called Packer, which is an open source tool that helps you to create multiple armies of different machine types parallelly. And on top of that, we use Ansible Galaxy playbooks. They are nothing but pre-configured Ansible scripts that allow you to download the CloudWatch agents, that allow you to download AWS Inspector agents so that you are covered from the security, monitoring, and also it encrypts the EBS root volume by default. So from encryption, from monitoring, and from scanning perspective, you're all good. On top of that, we are also using Ansible Galaxy Playbook for the OS hardening. That we use one hardening framework from devsec.io that does the basic OS hardening, like it deletes the unsigned packages, and also it restricts the use of root login and does all those checks as a part of the basic OS hardening. And then it creates a base army that's rolled out to different accounts. So that's how, and also on top of that, we run Amazon Inspector, which is a vulnerability scanning solution for all kinds of CVEs that are present. And when Hemanth talked about rehydration, so you have an army which is running there for almost 4 or 5 months. And then after that, a lot of patch dependencies and security vulnerabilities are found in your applications, in your setup. You should be all good by tearing down whole environment and building your application with a fresh army. That's how you kind of rehydrate your own environment. It's not possible unless and until you have such kind of a solution, which is kind of automated from scratch. So we use encryption and we use AWS Key Management Service by default. And we use encryption at rest for all the services, whichever AWS supports. And there are 2 ways of doing encryption at rest for different resources like S3 buckets and RDS. So AWS gives the option of using CMK, Customer Managed Key, or AWS Managed Key. So for critical data, which is PII in Neiman Marcus, we use a CMK, Customer Managed Key, because it allows you to rotate the keys. It allows you to put fine-grained IAM policy controls on the key. And also, it allows you to schedule it for deletion. And for all less sensitive projects or the data, we use AWS Managed Key. So this diagram basically sums up everything. We have all these services, right? We have Macy, we have GuardDuty, we have CloudTrail. You have a lot of data sources and data coming from everywhere. How do you kind of put a foundation layer and create some kind of an incident response mechanism? So if you see at the diagram, you can see a Lambda engine in the middle of the diagram. So this Lambda engine, basically, the same technology and the same workflow is being used by a lot of third-party tools. When I mentioned about CloudSploit has its own Lambda engine that basically triggers on based of the alerts coming from CloudWatch alarms, coming from your CloudWatch events. And if you talk about the Amazon GuardDuty and Macy, all these logs are being fed to Lambda engine. We can have a huge Lambda engine where you can have a lot of functions, and you can actually create those functions based on different use cases. And all these alerts can be configured and sent to Slack, or it can be sent to your traditional SIM system. I know there are some things missing in this, like WAF logs and other network logs or endpoint security logs, but this is something that you can set up as a foundation layer for your incident response. There is a lot of things that you can do post this diagram. For example, if there is an event where an S3 bucket is set up, which is unencrypted, your Lambda function triggers in and it sends an alert to your Slack, but you can have another Lambda function that actually encrypts that S3 bucket. So you can have auto remediation. So you can do a lot with Lambda, and you can actually have different use cases where you can put that auto remediation factor. That's all. So good for that.
Any questions? Sure. Go ahead.
I have a question about Macy. If you're still in the hybrid model where you have an AWS on-prem, are you ingesting any of your on-prem logs into Macy, or is that too expensive?
Yes, I think we're ingesting the logs, definitely. So
It has to come off S3. Right?
it has to
Yes,
come off
that's
S3. It has to. You do have to ingest, but again, for them, S3 is very cheap, but and ingestion is cheap, but it's only exit, which is a problem. But you have to be on AWS.
Done that with any on-prem logs?
We are working on moving our on-prem log, but Macy is not just focused on log data. It's also the actual data, source code, other data. Yeah. But we are mainly using it in the cloud today. We're not. We are in the process of a transformation to go to the cloud. So most of our on-prem systems are eventually planning to go to the cloud. So.
And S3 is the only service that's currently compatible with the Macy. There are a lot of other services that are being kind of introduced, but I don't know why.
Even with CloudWatch, you have to go like CloudWatch to S3.
Correct.
That's right.
And so they are going to add other.
Yeah,
different sources,
I
yeah.
believe so.
Okay, great.
I think for that one, the GuardDuty basically also playing a lot of
Yep.
important role.
Yeah, GuardDuty plays
That's
a
right.
very important role.
Especially like instance management is a lot of stuff, talking about forensic stuff,
Uh-huh.
and to catch an event, and I think Guard Duty be able to also catch those events and put the machine into a private group and also...
Correct. I mean, you can contain the machine and take a memory snapshot, stop it, and then contain it to a one particular restricted network where only your security team can log in and SSH to the box so that you can do the forensics later. Yeah, you can do that.
The other one is also, you have one slide talk about your image build-up.
Correct.
Why you give the flexibility to your developer to do so? Why not just predefine some cloud infrastructure as code to let the cloud formation to basically build in those?
Oh, yeah. When I say developers, I'm talking about the infrastructure developer. We call everybody developers.
Platform teams.
Yeah. We are building the hardened image, and only those images are valid to be deployed. Nobody can deploy anything other than the hardened image. So we restrict it.
To like the immutable infrastructure concept to stop the people apply the patch.
In the production directly, yeah.
Yep. Sure. Oh. All right.
How are you automating the use of OWASP proxy for the pen test portion of it?
Oh, it's currently manual. It's a manual testing tool.
And how are you feeding the results back to the development team?
No, actually, as a part of the Jenkins pipeline, right? So OWASP app comes up with a score, right? There is a score which comes up, and then we have a cutoff beyond a certain score. If you have, I think it's a high, medium, low kind of thing, and if there's a certain high, we prevent the pipeline from going forward.
Yeah, that was going to be my next question. So that's how you're tying your policy to the security gate. Yep. And then, so if you reach that certain threshold,
correct,
what do you do? Do you basically
we just stop the pipeline.
Build?
The build will stop, but we introduce it kind of in the more on the pre-prod stage, not in the early dev stage. I think we want to kind of move to the left, but right now it's a pre-prod stage, and we just stop the build and send the pipeline will send a notification that this test failed, and it's up to the team to then fix their vulnerability.
Thanks for sharing. So you mentioned quite a few things. You mentioned, virtual machines. You mentioned, serverless.
Yep.
There's also, infrastructure. So, from a, I guess, a risk and control perspective, right? There's a new term. It's not point-in-time compliance. It's continuous compliance.
Correct.
Right? Correct. So have you implemented, building your own products, or you look at any vendors to figure out, how do you keep all of the configuration management and continuously, monitor for the compliance if something happens, whether you, put it back and notify or just notify, not putting back?
Correct. So as I mentioned, we use a wide variety of tools, right? There's no silver bullet. There's no one tool, right? So Amazon provides some tools natively. We use some of that. Cloudsploit is another open. There is an open source variant and a paid variant, which will continuously monitor your compliance, right? And also shows you history of compliance, so it maintains a history. So today you could look great, but you can also look 3 months ago how you looked, right? In terms of errors and warnings and whatever. So yeah, we do use a wide variety of tools. Most of it we touched today in the presentation.
And the focus in your case mostly on detective controls or preventative?
They're preventative, right? For example, where we do Cloud Custodian is very preventative, right? It's as we have a policy, right? Say we have a policy that you encrypt everything, and that's a preventative control right up front. The build pipeline will fail if some of those factors are not met.
And we do a lot of preventive controls on the IAM part of it as well. Yep. So we have policies on the IAM level where we restrict developers to spin up anything safe in Virginia. So ours is mainly, I think, US West 2. And if he's trying to spin up in another region, then we restrict it at the IAM level. And if we can also restrict them for spinning up resources that are they can't spin up C4X large. They can only test out with T2 micro. So that's how we do cost control as well as some of the security features at the IAM level.
Okay, are there any more questions? All right, thank you, Omar and Hemanth.
Thank you.